Surveillance car bot. Future of surveillance car bot. Abstract. We will discuss how to control a robot-controlled car utilizing a Wi-Fi module and a mobile phone in this paper. For spying purposes, a new version of a wirelessly operated car has been proposed. This robot is a portable espionage robot with a wireless communication system. A camera, motor drivers, batteries, and 2 moving wheels make up the spy robot. The AI Thinker ESP32-CAM module has an ESP32S processor, an OV2640 camera, and a microSD card slot. Images captured by the camera can be stored on a microSD card slot. The HTTP communication protocol will be utilized to receive video streaming from the OV2640 camera via a web browser in this case. The web page will also have buttons for moving the car left, right, forward, and backward. We used 2 DC motors with robot chassis and L29 motor driver module to make this robotic car, in addition to the ESP32 camera module. The signals from the user's smartphone are utilized to move the vehicle in this vehicle, and the video is live streamed via a camera mounted on the robot. The user's smartphone receives this live streaming data over the Wi-Fi wireless infrastructure. Keywords: camera, ESP32-CAM, smartphone, wireless camera, OV2640 camera, motor driver. Introduction. With the rapid growth of information technology, a range of video surveillance systems have become commonplace in daily life for surveillance and security purposes. Closed-circuit television, CCTV, often known as video surveillance, is an example of how video cameras send video signals to a limited number of monitors. When CCTV was initially introduced, its low quality and high installation costs restricted its use. Another common example is the dashboard camera. In the event of a car accident or vandalism, dashboard cameras can provide video proof. A CCTV is typically installed for surveillance in areas that require monitoring, such as banks and hospitals or areas where security is required. Therefore, its coverage is limited. On the other hand, as a car dashboard camera is installed inside a car, it can record while the car is moving. To perform car tracking efficiently, these 2 types of devices should be considered together. In the case of CCTV, as its location is fixed and its hardware performance is superb, it is highly effective for the monitoring of car movements in a predefined area. To have the ability of both, our system is proposed in such a way that it can be used effectively to handle traditional surveillance tasks that are typically both time-consuming and labor-intensive. For instance, one of the typical steps for the police to determine the movement of a stolen vehicle is to start with the CCTV and dashboard cameras in the vicinity and gradually expand to a greater area. Investigating all the CCTV records and dashboard cameras involved would require significant amounts of human labor and time. In the case of our system, based on the car number, time of the crime, and place, we can easily formulate a query to determine the detailed track of the stolen car. In addition, our system can be highly effective for other popular applications such as traffic congestion analysis by region, searching for optimal driving routes, access points and evacuation exits during accidents, and planning new road construction. Based on our findings, we propose a spy camera car system, integrated video-based automobile tracking system, that can collect video and display the user's real-time environment. To make the robot a surveillance robot vehicle, we propose combining a camera with the robot using the ESP32-CAM module. Apart from the ESP32 camera module, we will build this robotic car with 2 DC motors, a robot chassis, and an L29 motor driver module. 2 Literature Survey. V. Shankar Intelligent Combat Robot 2015, it has been described as developing a robotic vehicle for remote operation using RF technology and a wireless camera for monitoring purposes. The robot and camera can send real-time footage with night vision capabilities through a wireless network. This type of robot could be useful in war zones for spying purposes. In this technology, a robot can only be operated from a distance of 10 meters. Robot with Bluetooth control. With the increased speed, a new classification technique was presented to improve the robot's range. The camera's link was frequently lost with this technology. Jovita Sereo in a WABFAKI, mobile-operated vehicle, it's a notion in which a human can operate a vehicle remotely or wirelessly using an Android app without having to sit inside it. A car powered by a battery and a controller with Bluetooth connectivity are included in the project. The system is made up of a controller with a Bluetooth communication IC that will be connected to the vehicle's motors and other components. When an Android app that is connected to this system via Bluetooth is turned on, the vehicle can be controlled via wireless orders from the app. Bluetooth's range of operation is around 10 meters or 33 feet. Drive S. Bhargavi and S. Manjunath Electronics and Communication. The goal of this research is to reduce human casualties in terrorist attacks like the one on September 11, 2001. The combat robot was created to deal with such heinous terror acts. This robot is radio-controlled, self-powered, and equipped with all of the controls found in a typical car. It's been outfitted with a wireless camera so that it can keep an eye on the adversary from afar if necessary. It has the ability to enter enemy territory invisibly and transmit all information to us via its small camera eyes. This spy robot can be deployed at high-end hotels, shopping malls, and jewelry showrooms, among other places where intruders or terrorists may pose a threat. Heba H.O. Nasreddin and Amjad Abdullah Abdelkarim. They have used the Bluetooth technology to control robot using smartphone. In this proposed experiment, robot is controlled using Bluetooth, which has two modes. The first mode DDM called direct drive mode. In this case robot moves in all directions as per the user requirement. The other mode is MBM called map-based mode, in which MBA allows user to draw initial point and end point and obstacle, in order to calculate shortest path. So user can choose or use one of two modes to control robot using wireless communication. 3. Methodology with block diagram. Any robot structure, or body, on which its whole control circuits and actuators are to be attached, is a basic requirement. The fundamental goal of our design is to move the device in response to the button. As a result, we created a simple robot that can go forward, backward, left, and right by simply pressing a button. Components used: ESP32-CAM, FTDI programmer, DC motors, 2. Motor driver, L293D. Battery. As the ESP32-CAM lacks a USB port, an FTDI board is required to upload the code. The ESP32's VCC and GND pins are wired to the FTDI board's VCC and GND pins. The ESP32's TX and RX are linked to the FTDI board's RX and TX. Through the L293D module, two DC motors are connected to ESP32. The IO4, IO2, IO14, and IO15 pins of the ESP32 are connected to the module pins. The surveillance bot ESP32-CAM module has an ESP32S processor, an OV2640 camera, and a microSD card slot. Images captured by the camera can be stored on a microSD card slot. The HTTP communication protocol will be utilized to receive video streaming from the OV2640 camera via a web browser in this case. As indicated in the image above, the web page will also feature buttons to move the car in the left, right, forward, and reverse directions. Disconnect GPIO0 from GND after uploading the code. Use a baud rate of 115,200, open the serial monitor. On the ESP32-CAM, press the RST button on the onboard RST button. The IP address of the ESP32-CAM should be displayed in the serial monitor. Remove the FTDI programmer from the ESP32-CAM. Connect the ESP32-CAM to the pan/tilt platform again, switch on the power, and hit the RST button on the ESP32-CAM on board. You should open up your router settings. There you will find some settings, including something along the lines of forwarding or port forwarding. The important thing to note here is the port range and the device or IP address. In port range you should type 80 to 81. For device you should select your ESP32-CAM device. In some routers you should put the IP address of your ESP32-CAM instead of a device name. The live video captured by the camera will be sent to the Android application by which we will decide the movement of our vehicle. 4 expected outcomes. A. Although these robots simply offer us with the live footage of the scene, it can't engage or offer facts about different aspects. However, there are numerous uses of this bot for analyzing diverse situations which might be dangerous or inaccessible to humans. There are many situations, like mining accidents, urban disasters etc., that require the usage of remotely controlled surveillance robots for assessing the harm and developing the strategy, for viable access points and evacuation exits required to face the task and save lives. Human surveillance is carried through skilled workforces in close sensitive regions of war area or adversary territory in order to constantly look for changes. Whereas there's usually added risks of losing workforce in the time of getting caught by the adversary. With developed technology in pasted years, there it is possibility to keep the important regions under surveillance remotely by the use of robots instead of human. Some regions want to be positioned under video surveillance for a brief time, and consequently equipping them with desk-bound CCTV systems isn't always viable. Such demanding situations regularly rise up in agricultural settings. For example, the fields may only need to be positioned under video surveillance whilst the vegetation are attaining maturity. Surveillance of pastures is effective only when farm animals are roaming round them. In addition, pastures, fields, and hills which can be most desirable for surveillance do now no longer, in maximum cases, have an energy supply. For the agricultural sector, cellular video surveillance by the usage of the surveillance robot car is a lot more helpful than opting for desk-bound surveillance structures. Mobile robots do now no longer require setting up highly priced infrastructure, setting up poles, or laying down cable, and hence becomes much more convenient and economical. B. Application with scope. In any circumstance involving technology nowadays is a must. Robots is one of the future necessity. Virtual safety is a requirement. Patrolling. Regularly patrolling the streets to keep people safe and assist in notifying the authorities as soon as possible. There is a very slim probability of receiving inaccurate or biased information. Identifying, collecting, and rapidly submitting information to authorities if it matches any person's criminal history in its criminal database. For instance, if some criminal is on the run, the bot can send police a message with its last location. Application in the military. Certain places are only for gathering information and monitoring, thus this surveillance car bot can surely be used. With advanced upgrades, we can provide data instantly and carry out military action as needed. Applications for air traffic. It can be used to monitor traffic rules, persons wearing helmets or not, and car seat belts. In COVID circumstances, people wear masks and maintain social distance. Concerns about the environment. Cleanliness is encouraged, and online fines for not following standards and fouling the environment. Playing brief voice notes to remind individuals to follow the rules and keep the area clean.